Hi, everyone. Welcome
Um,
to this month in consumer electronics, which actually comes up twice a month.
Hey
Great.
everyone.
Oh, go ahead.
Oh, just welcome. It's great to be back at our bi-weekly monthly talk.
We can do intros since
Yeah.
some people haven't, seen our show before. I'm Brian Tang. I'm a senior solutions architect at AWS. I work with manufacturing customers. Been here for about four and a half years, and based out of Boston. And, Krishi?
Hi, I'm Krishi, and I am a solutions architect on Brian and Chris's team. I deal with electronics companies, and I've been here for 8 months. So, yeah, that's it. That's about me. Chris.
On. Yeah, Chris Jordan, also a solutions architect on their team, and I just completed my 3-year anniversary last week at Amazon. So happy about that.
Congrats.
But also do support the same customers in the same vertical, some of the semi-manufacturing customers. And yeah, looking forward to today's session. Thanks for hopping back on and doing and having some fun with us today. So pass it back over to Brian and Krishy.
Okay. Yeah, before we jump in, we've been working on the theme of a smart home, pretty much doing system design around different aspects like what kinds of control do you have? How are devices deployed? How do you manage firmware? How do you manage the fleet of devices out in the field? What cool stuff can you do with them? I think Krishi led the last session. Great job. If you don't mind giving a quick recap of what we did last week, that'd be excellent. And we can jump from there.
Yes. So last week we tackled the exciting topic of how to secure your home using a smart lock and an AI-powered smart lock, right? So we talked about how to onboard devices using AWS IoT Core, and then we pushed firmware updates. So our lock is constantly getting the most up-to-date software and firmware. And then the last thing we did was learn about how to incorporate AI features so that our lock is able to predict when it should keep our home secure, even when maybe we kind of forget to do the lock, or if we have other people that are coming in, need to delegate permissions, access, when you have maybe some contractors coming in, all that stuff. So what we did was look at how to store relevant data into a database. And then we used Amazon Bedrock to generate chat help through our phone app for the smart lock. And we leveraged Amazon Q and Amazon QuickSight to understand analytics around how our smart home door lock is working over time, locking and unlocking and features around permissions. So that's what we covered last time, and I believe Brian is leading today's chat, continuing on that theme.
And with that, I'm going to kick off some lo-fi music. Not too loud.
Yeah. Yeah.
There we go. All right. And yeah, so what we want to do is continue on the theme of introducing AI ML into the smart home and maybe do a bit better job together of figuring out where we might deploy it on the edge or in the cloud and how we might want to do that, why we might want to do that. And for instance, what I'm thinking about is thinking of using a powerful edge device. Like, I don't know if this is not an endorsement, but it is an example of what you might want to use. In this case, it's a AI computer that's on the edge. And the advantage of these things is that they're much cheaper than a PC gaming desktop setup that you might have, right? It's like $250 versus a $3,000 gaming rig, which means you can deploy more of them. And if you're a factory, you would deploy a bunch of these on an assembly line and be able to connect, say, a camera to it and start looking at things and trying to find defects or trying to look for things that are out of the ordinary. And in your smart home, for instance, is just what we're talking about. You can do really cool stuff. So I was chatting with Chris the other day about one of my friends who has a pet lobster. And he started a Twitch stream for his lobster as well. I'm not going to share it here because I don't know if I'm allowed to. But what you could do would be to really get a better, more powerful way of working with your lobster would be, recognizing, pointing a camera, connecting an AI computer to it that's like not super expensive, and be able to detect things like, oh, what are the patterns it moves around the tank in? When does it prefer to eat? When is it molting? Because when it's molting, you don't want to miss that. It's a very exciting event, and things of that nature. If we're talking about like a smart lock, for instance, and maybe you want to have like a camera recognition, like let's think about today how we want to have something that can easily recognize your face or people that you delegate, I think is what you called it, Krishi.
Yeah.
Yeah.
Yeah. Oh, really quickly though, I wanted to ask the chat if anyone has a Raspberry Pi or has deployed LLMs or AI onto it. Just let us know while Brian talks about you're setting up at the inference at the edge, right?
Yes, inference at the edge.
Okay.
Or also something cool would be just to hear where people are dialing in from.
I'm answering for the chat because no.
Thanks, Chris. Oh, you did.
Yeah.
Well, no, tell us about it. I'd love to hear
Oh,
about it.
you know what? It was such a long time. I think it was such a long time ago. It was just for a class, so I honestly can't even talk about it right now. But I hope someone else in the chat can. Feel free to put your comments in the chat.
Honestly, I've never played with a Raspberry Pi.
We got a comment here. We
Cannonball
got an
Hill.
emoji.
We got an emoji.
Okay, quick question. What is this an emoji of? Because it looks like...
It looks like a lemur or a monkey.
Okay, I was gonna say Albert Einstein with like the wackiest sunglasses, but that's because I can't really see the image.
I'm not out of touch, I swear.
I'm just... Well, okay.
Okay, so
As you were saying.
I think what we can do right now is at least write down some of our requirements as we normally do of like what we wanted to do. So really quickly, we said we want maybe local cam vision. Doesn't have to be a lobster, but for now we can just say we want to be able to, let's go along the smart lock example, right? We want to be able to detect a person's face, and then we want to be able to recognize that face as well. You could expand on that, right? So like recognize packages or like recognize a pet. I think in our first episode, somebody had talked about being able to dispense food when the pet is like close by or something like that. And maybe you're dog sitting and you have a lot of rover dogs, and you only want to dispense certain food to certain dogs when you recognize their faces, something like that. Nothing too crazy. What do we need to do on the device, right? So in order to do the inference, you need the vision model. And that could be, I don't know, the one that I looked at most recently was called YOLO V8. And what else might you want to be able to do? You might want to have the embedding model. So
Okay, Brian, are you trying to share your screen or not yet?
Oh, whoops. Sorry. Here we go. Thanks, Cushy. Right. So we want to detect a person's face. We want a vision model. We want an embedding model. And then eventually, in order to actually do stuff, you actually need the code itself. So you need the application code. We can call it inference code for now, unless that's a technicality you want to correct.
Me? Inference code sounds great. You mean the code for the inference pipeline?
So like when you want to actually run the code, right? So for instance, you need to import that model somewhere, and then you need to use it, and then be able to use that, use whatever data you're getting and compare it to what you have stored locally, and then say like, this is the person I'm looking for, or this is not.
Inference pipeline.
Inference pipeline code.
What role does generative AI, play with IoT devices continuously streaming data? Can we expect real-time personalization on the device itself? Pratik, awesome question. Brian, do you want to answer, or do you care? No?
I can answer with what I know, and then we can see where we go from there.
Okay, I can also answer if you want. But you go
for
first.
it. Oh, okay.
Okay, so with real-time personalization on the device itself, yes, you can do, that's what we call like inference at the edge. You can use a model, right? It can be pre-trained, you can train it yourself. But to get like that personalized recommendation, for example, using streamed data, you just need the model on the device that you're looking to generate the predictions, which we're calling inference. That's the industry terminology. So when you're asking about what role does Gen AI play, so Gen AI is like, think about it like it's the model, like it's the large language model, LLM. So it helps with, these days it can help with images, but historically we started with text. And that's like that pre-trained model that you can then use to do real-time personalization on something like that device that Brian showed. So does that help, Pratik? It works very similar to traditional machine learning, but instead of having to train the model yourself, you can use pre-trained large language models, which makes the lift a lot easier for us.
So one other thing I would add is, yes, you would love to have like really powerful models on the edge. But like I mentioned, there's some resource constraints, right? Maybe you don't have enough memory or storage or compute to run like a super large language model. So there are some open source ones. There's a lot of projects out there where you can see people having deployed a 7 billion parameter model to something like that Orin Nano, right? For instance. And what you need to do is like, you still need something like a 1 terabyte SSD, like an NVMe SSD, to be able to store something of that nature. So yes, there are things that you can do at the edge. You can have Gen AI on the edge, but you are constrained by how much resources you're able to allocate there. But once it's there, yeah,
70 billion is possible. I just looked it up. 70 billion parameters
on the Nano.
I don't know about your device. I just mean like it is. I didn't know that was even like a thing.
Well, yeah, I've definitely seen somebody use like what is it, RTX 4090 GPU PC with like 64 gigabytes of memory, and then they were able to load up like hundreds of billions of parameter models on there. So it is possible. But with the power of the cloud, you can actually use Bedrock and abstract a lot of the all of the infrastructure that you need to access things like Anthropic's Sonnet 4 and other models that are, how many billions of parameters are those at? Off the top of my head, I don't remember. Much bigger than 7 billion that can go on the edge.
Yeah.
Okay. Allison mentioned that Bro's face is covered with a YouTube icon.
I did, so the comment's no longer relevant.
Good observation. Okay. Okay, so we talked about having what components are at the edge. So I'm just going to call this an edge device, not the smart lock itself. We said we need the vision model. Let's say like face detection models, and then we want the embedding model. So essentially, we're gonna at the beginning when you unpackage the device or you want to have a baseline of things to compare to, you want to take a bunch of shots of your face or like videos of your face, and then there needs to be something that can convert that into numbers that you can use to do comparisons. So that could be deployed onto the device as well. And I think it's called like Face Insight or something is the open source Insight Face, I believe. Yeah, there we go. It's like one of the models that you could use, and there's some libraries that you can use as well to create these things. And what you want after doing this would be like lightweight embedded database, and you could be files, or it could be like SQLite database that you deploy onto this edge device. And then we mentioned that we need the inference code to glue all of the inference pipeline to glue all of this together and make your predictions. And then something else that you might need, because you're thinking about not just this prediction, but maybe some log and metric code. And this can be like MQTT messages, HTTP messages. And when I'm starting to think about this type of stuff, I'm thinking more like enterprise grade. Like we have a platform and we want to take all of this stuff that's happening with these smart lock devices we deployed in the field and be able to do useful things with them. All right, we got another comment.
Okay, so GVO Cypher is asking AWS recognition. I'm going to are you asking if this is similar to AWS recognition, or how this might differ in terms of like, oh, okay. So can we use AWS recognition instead of using an LLM with all of these open source libraries?
Well, the use cases would be different, right? Like the LLM, I would really lean on it for chatting. So like say like I have a bunch of data and it is like maybe it's semi-summarized or whatever, and you're really talking to the LLM to summarize things, not necessarily to do the face prediction. Like I don't think I would lean on an LLM to say, please recognize my face when it comes here. I would use this model that is specifically trained, like a machine learning model that's specifically trained to understand faces, right?
So,
I think,
yeah, that's a good point. And like, okay, so for AWS recognition, that is it's good at doing computer vision tasks that have object detection for like commonly known objects like stop signs or like celebrity faces. It gets a little bit trickier when it's something very specific. So that's where Brian's saying you'd need like a pre-trained right, Brian? That's what you're saying, like having a pre-trained model or doing transfer learning or like other techniques to improve that model's output for that specific circumstance, like recognizing your friends' faces from people that you don't know, or recognizing like neighborhood dogs. Like that's really specific rather than just recognizing any dog. So you can implement recognition to do something similar, but it would not have the specificity that this design has. So that's what I would say. Does that make sense?
I think that makes sense.
Yeah. Okay. Awesome.
All right. Any thoughts on implementing? Any thoughts on implementing AWS recognition in the workflow? Yeah, like we mentioned, I'd say like I would classify AWS recognition as a managed service. So it may not be as customizable. And I personally haven't seen like a managed service deployed to the edge like that. I think if you're trying out a lot of vision use cases, it definitely makes sense to lean on managed services like recognition to see like, oh, can it do some basic things in the cloud that I want to try out, like recognize stop signs or like recognize street signs, or be able to do basic things like that. Okay. Oh, Pratik, another question. Chris, you want to take this one?
Let me read it. Have you seen enterprise banks use IoT plus Gen AI to deliver hyper-personalized services across thousands of touch points? ATMs, kiosks, smart branches without compromising security requirements. So we don't work with financial services clients, but I guess we could take this in a direction of more so like IoT related. I mean,
I said this team specifically, we work with manufacturing and consumer electronics, but we do have a FinServe vertical, and they probably intersect with this as well.
So in terms of use cases like IoT and Gen AI for hyper-personalized services, and things like ATMs and kiosks and smart branches, the architecture that Brian is going to walk through, it could theoretically be used in, different, like in these different scenarios. Because like Brian, like you're talking about it, and from a manufacturing lens, but you could also use this in financial services, but without compromising security or compliance. That is something that I think we can touch on if we have time, using some of our newer services like Bedrock, Amazon Bedrock Agent Core. But it's more about how you design it, not if you can do it. So that's the short answer.
Yeah, I'd also plug the our financial services vertical here, and there's a lot of use cases and stories and case studies that are covered on that site. So if you have a chance, take a look at that, and you might get some good ideas.
It's super effective for helping you.
Thank you.
Trying to find a blog post if I can before the stream ends that specifically addresses that question. But yeah, great question, Pratik.
Cool. All right. We talked about some of the things here, and let's add a note that these can be pre-trained, and there are open source models to do these things. Just in case somebody jumps on midstream and they're like, what is going on here? Let's see. I think I have some good arrows. Do I? Great. Oh, I can't see that. Black. Perfect. How's that look? Oh, other things in the inference pipeline you want to think about, not just using the models, but you might do some cleanup, right? You might have like a cropping function, or you might do some other types of like normalizations. And then you would do the comparisons within what was stored in the lightweight embedded database, whether that's like your files or using SQLite or something like that. We got more questions.
Yeah, I just wanted to plug in this blog. If you want to just copy and paste this or take a screenshot of it, this is a pretty good blog that I just quickly found on building an AI stack for banking on AWS. So it does touch into the elements around ATMs, banking, and potentially like ready-to-use applications that can at least provide you some additional context from your Ask Pratik.
Yeah, I think it's published to the Twitch chat, so that's why it's not in the YouTube chat, but hopefully you can copy paste it from the banner.
Yep.
All right.
Here, I'll leave it up just in case.
Yeah, we can just leave it up. Oops, I copied the wrong icon. So going back to Okay, what about this is AWS, right? So right now we talked about these open source models. We talked about creating the pipeline. Obviously, there's Amazon Q Developer, which you can use to help you create the inference code and then deploy it to your device. But what you might want to think about as from the perspective of, say, like I am a platform provider for this device, I would use something like Greengrass on here as a way, and we've talked about this in prior episodes. You use this as a way to connect your edge device to the AWS cloud. And there's a variety of reasons why you might want to do that. For an enterprise, it would be things like, I want to capture some pre-aggregated information that I can use to do more important things. So for example, like if eventually I want consumers to be able to chat through the application about the state of their smart home, then this would give us an avenue to deliver that kind of value to our customers. And what might that be? So for a smart lock, it would be, as a user, I might ask something like, okay, tell me about like the top 3 weird things that happened over the last week with my lock. And then it would be able to, you would lean on the LLM to be able to look at a summary of some of the events that had happened. But then you want to be able to also lean on some tools to make it easier for the LLM to summarize what that information is. So like a not great use case for AI would be looking at a database and asking the LLM to like summarize that data, right? It's a very inefficient use of its ability to generate insights. Rather, you might want a tool or some sort of like process to crunch up and give you like a high level of, okay, there were like doing queries on the raw data itself, and then getting some sort of output, and then having the LLM look at the output and then tell you whether it's weird or not, if that makes sense. Does that make sense?
Yeah.
Yeah.
I think the reason I wanted to say it that clearly was because there's a lot of talk about like agents and like LLMs and tools and like MCP and all that gets thrown around. And maybe it's a good idea to like disambiguate what that is for the audience if they're interested. Are they interested? I mean, I can continue on and just finish off this thought about what goes to the cloud with Greengrass. Okay, so I want to have an arrow, and these are things we talked about. So there could be MQTT messages, which is basically like a protocol that makes it
Okay.
more. Yeah, go ahead.
I think somebody is talking about or is asking a question on what you said. Why isn't an LLM good for databases?
Oops. All right, let's answer this one first. Krishi, what are your thoughts?
Oh, well, okay. I think you mentioned it, so I'm not sure if you had like a specific use case where LLMs aren't helpful for databases, but I think it depends on how you craft the question so that it reflects more of a query. Otherwise, I have seen LLMs actually be pretty helpful for getting high-level information or analytics from structured databases and unstructured depending on what's in there. But Brian, I'm going to let you answer because I think you mentioned that you had a specific thing that you were talking about.
Okay, I think let's frame this in a couple ways. So there's deterministic versus non-deterministic. I think that is like the main thing you want to think about when you're deciding whether or not to use an LLM to do a thing, right? Deterministic means every time I run this function, I should get the exact same output. What you should think about with LLMs or AI in general right now, at least at this moment, it could change, is that every time you ask it to do something, it will not guarantee that it's going to return exactly the same thing. And you kind of see that when you interact with a chat, and maybe you ask the same question twice, and it will vary because it's like taking a whole bunch of things and then it's predicting like what is potentially a good output. And so that you would call that non-deterministic, because every time you ask it something, it will give you a slightly different answer. And so when you're talking about like, I want to interact with a database with an LLM, that's usually, so people are asking about text to SQL as a function. And something that's changed for over like the last 6 months I've been working with customers is that at first people were like, okay, let's just throw text to SQL as an answer to like interact with databases. But then you always get a little bit slightly different output. And when you try to build these like really long, complex queries behind the scenes, like a lot of enterprise databases could be like hundreds of tables and there's like dozens of joins. And when you ask a basic question, it has to figure out like what are all the tables, what are all the fields, what are all the joins, and then it has to create the SQL query, and then it has to try it multiple times in case it fails, because sometimes the queries don't work the first time, right? And so what's happened more recently is people found it, oh, it's like really effective if we have really common queries and to do reads and writes, and we expose that as a tool that the AI is then aware of. And then it's aware of all of these things that it's allowed to do or that it can do. And then it's able to execute the task really effectively. And more importantly, it's not burning a lot of tokens, right? And tokens will drive cost, and it will also affect performance. So if you're able to give it the right tools to do the job in a more like the tools are deterministic, but then the AI is aware of all the things that it's able to do, it can more efficiently do the task faster and like cheaper. Let's see. Yeah, let AI random destroy your house. So I'm not saying that
here's another question actually. In large manufacturing setups, do you see Kafka being used alongside Greengrass to reliably stream high-frequency sensor inference results from the edge into cloud analytics pipeline?
Yes. You can set up Greengrass. Actually, if we go back to an earlier...
Yeah, those two services actually be complementary to each other. I think we have, this actually a good diagram right here.
Yeah, so this was an earlier episode where we had talked about, okay, what would you do? It's the same idea, but on the edge, you have a broker or a device itself with Greengrass, and then be able to connect to IoT Core, and then sending some information that's maybe MQTT, and then you have rules that are set up in IoT Core to make it easier to route those messages to the right place. In this case, we have Amazon Kinesis as like the service that's doing the stream processing or like stream ingestion. But you could swap that out for managed services Kafka or Kafka deployed on AWS in this case to do that stream ingestion. So yes, and then at the tail end of it, we don't have it here, but we have it here. You would eventually, all that data would land in the analytics layer where you can visualize it with QuickSight, query it with Athena. This is actually Amazon Redshift. There's a data warehouse if you want to do trend analysis and a lot of aggregation. Yes, you can.
And I know you mentioned financial services use cases as well. This could be applied in that same vein of potentially having your ATMs or your different kiosks that are pushing event logs to Greengrass, and then from there you can be able to push those interactions, those event logs back to Kafka, so to be able to have more like personalization in terms of like personalization engines for your users, right? So that is a common complementary type of pathway that we see not only in manufacturing but also in other industries as well. So, and I think that initial post around building an AI does talk a bit about that as well. So yeah, but great question, Pratik.
All right. Let's see. So we talked about deterministic, non-deterministic, when to use AI, when to use machine learning models. We're not saying you give MCP access to everything and let the AI run amok, right? So think of AI as like a helpful assistant. It's not intelligent by itself. It's literally just trying to determine what makes sense to do here. And in a lot of cases, it's like very simple stuff. You give it exposure to all the tools, and then it is able to show you its reasoning, and you can even add guardrails to say like, before you do anything, like it has to be approved, and then it would execute. Yeah, correct. Okay. Designed to generate. There is some reasoning there as well. So like if I were to give it the, let's say, what's a good example? You would have a tool that would understand the weather. You would have a tool that understands like activities in a particular city. And by giving it knowledge to these tools and the way that you define them, usually through like comments in the code itself, it will know that like, tell me something that I'm able to do today in Seattle. It would be able to list out like all the things that you can do in Seattle, the current weather in Seattle, and then be able to identify, okay, what are the events that you typically wouldn't do in the rain? Like very basic automation like that. Okay.
I'm actually curious about what you were going to talk about with Greengrass and how it ties into the cloud, Brian.
Sorry, going back. We were talking about the stuff that we want to be able to do at the edge, but then there's more enterprise stuff that we had talked about in prior episodes, right? So being able to capture critical information, and we're not saying that we're going to feed it to AI, but that we need to use this information to give users something helpful as like a service provider. So say you're using IoT Greengrass, you're able to capture MQTT messages, and then you send it to IoT Core, which is our managed service for IoT things. I feel like the text sizes are triggering me, but let's keep going. You can send the messages to IoT Core, and there are different topics like we had talked about before. And then there's different rules that you can have in place in this managed service that can route the messages to the right place. So for instance, very commonplace for this data to be routed would be something like S3. And the reason that we want to do that is because it is an object store that allows us to land data in a staging area before we decide what else we want to do with it. And like all things, it depends on how fast and how much data is coming in and how frequently it's coming in, where you decide whether or not do I need some sort of buffer in front of the S3 bucket in order to handle like quota limits or things like that. So something like data fire hose is something that we talked about earlier as well. That can serve as our buffer. I have it somewhere. Okay. Here we go. I'll just stick it right here. Other landing places from IoT Core via like an IoT rule. Let me just make sure I can put that here. This gives us a sustainable way to route all our messages to the right place. In some cases, you might want to route it right to a streaming service.
So why would you need a buffer before you send the data S3?
Because if you're so maybe you're thinking about like quota limitations of like how often I can hit the API. If you're getting like, more than, I forget what the rough guideline is, but I would look at the quotas and then I would determine like if it's, for example, you're getting more than like 50 megabytes per second of like data coming in. You may not want to just like every second, you may not want to just like keep hitting the S3 API. You may want to go for a managed service that can handle those, like batch them together and then do one write efficiently to S3. And there's a multitude of reasons you would want to do that.
I think a big one is cost as well, right? So using Firehose as a buffer in this scenario would significantly reduce cost in terms of just like overall how you're applying formats and how you're actually batching the different data files into one. So I would say I've had some customers that just have used this type of workflow just because of cost savings on this part.
All right. I would have to ask the service team why it's built that way, and I'm sure they have a very good reason. I mean, we can take that in our back pocket. Okay, and then for say if it's not like say we want to have it handled by a streaming service, we would also have, let's see, we already talked about this. There are native ways you can talk to something like Amazon Kinesis for streaming data. And again, that matters like what streaming service you're familiar with. Like if you're more comfortable with Kafka, you may stick with that. If you want Kafka, but you don't want to deal with a lot more of the infrastructure, you can look at a managed service like Amazon managed services Kafka. In this case, this is like the fully managed AWS native streaming service, Amazon Kinesis. That could be a target for an IoT rule as well for these MQTT messages. And others that you would think of could be like Amazon DynamoDB if you just want to land the data in a NoSQL database, or if you want to do some sort of like subsequent downstream processing and you're really heavy into serverless, you would lean on EventBridge and then Lambda to process that. I'm not going to draw those out, but for now, we can just have this like more batch way of doing things and more streaming way of landing the data. Something else that you might want to consider on the edge. Let's see. Okay, Frank is excited about the high value content. So let's jot down reasons why data firehose versus not. Okay. Actually, I do want to talk about the EventBridge pattern. So you often hear about like event-based, event-based architecture. I wonder if I have EventBridge anywhere. Don't think I do here.
And I just wanted to highlight what Chaos said. The edge device can do the hard work and do some object face detection and then send that result via MQTT. Yeah, that's correct. I would say that's best practice in terms of edge plus sort of the cloud IoT pattern. So definitely correct. Chaos.
Right. EventBridge. And if you've seen some reInvent talks about customers that are also in consumer electronics, they do a lot of event-based architecture as well. And it also opens up to like, there was a whole talk about cellular architecture, and that's where you get into, okay, the reason I might be, the trade-off of going with like event-based processing is that, yes, you can isolate a lot of the different processes that you're trying to run. Another benefit would be you're able to improve resilience. In some cases, multi-cellular architecture, they deploy it in multiple regions, in multiple AZs, and they're able to make sure that if there's an issue in any particular area, that the critical platform service is up and running, especially for something as critical as blocks. But the basic idea is that they have EventBridge processing events that are coming in. In this case, we're trying to say you do some sort of pre-aggregation before you trigger these things, so you're not like firing off events every time like a status check comes in, right? Because then you're being a lot more noisy than you want to be. And we're getting more questions, so let's jump on that. Oops. In this setup, how do you decide what stays on the edge versus what gets streamed to the cloud, especially when running multiple models like LLMs and embeddings are on resource-constrained devices? It depends on the use case, right? In this case, our use case is well defined, which is we're saying it is a lock where if it recognizes my face or my family's faces, then it unlocks. And then in the details of like, okay, why would I run multiple models like LLMs? In this case, it was an idea. I'm not saying that we do it or it even makes sense to run the LLM locally. Like the only reason I would run an LLM locally, which I'm going to try to do, is just to get snappier responses and see what it is like deploying an LLM locally. I don't think right now, for at least for my use case, is that feasible. Like I wouldn't ask it. There's not a lot of things I want to ask locally right now, unless you guys can think of one.
Well, I mean, no, I would say like there could be some personal use cases if you have a device like that. Like if you live in a remote area that doesn't get internet access and you still want to be able to leverage something like an LLM for personal assistant tasks or summarization. I mean, people use it for a lot of things these days. Then it could be interesting to have an edge device because there are remote areas, but people may still want the advantages of LLMs. That's the main thing I would say from a personal use case. But then from a business use case, there are a lot. You know, you may just need minimal latency, so you may need an edge device to help provide that when it comes to response times and processing the data produced by different machines or sensors that are on site, for example. Deciding what data stays on the edge versus not is really like a cost benefit scenario in terms of like, okay, well, how big is your device? What kind of data do you need to provide the performance that that use case requires? So it's a tough question. There's no right or wrong answer. It totally depends on the need, the capacity for the device, and the type of data that is even being streamed.
Yeah, and I think Frank's comment about running on an LLM on an Apple M4 Max, they can fit a lot more. They can fit larger models than I can on my Aura Nano, right? Because I've only got 8 gigabytes of memory. So that's why I'm maxed out at that 7 billion parameter model. Yeah, and I would think like if you have a smart device, a smart lock, right? It's not going to be much bigger than this Nano that I have. So I don't expect I'd be able to fit like something really large there, unless you had, we talked about earlier in the smart home, where you could have a local broker that's probably more powerful than my smart lock, and maybe you have an LLM running there, and that's where you interact with it, right? And then you can be able to have snappier answers, isolated in your home network, that tells you things you want to know about the different devices in your home. Okay. Not necessarily laptops, just laptops, right? You can run it on your desktop as well. And again, like what we said about your whatever edge devices you have. But you have to think about, why are you deploying an LLM locally? And if it's a smaller model, can it get you the results that you're looking for? If so, then it might be fine, because the chatting with a LLM locally, it's pretty zippy.
Yeah, I think like the decision to use something like an edge device for personal use cases is more for like, you know, curiosity or enthusiasm, or if you want to isolate that, you know, workload, right, that's using the LLM onto its own device so it doesn't mess with your laptop, because there are a lot of like dependencies that, you know, you might need to install. And I know for me that has actually hurt my laptop before. That's the one reason that I don't like running LLMs locally, actually. I don't have a fancy M4 chip or anything on my personal, so it just depends. But I think for personal use cases, you can most likely use your laptop up to a certain size if you're okay with installing the dependencies and possibly, the ramifications of it.
I know we're coming up on 9 minutes. 9 minutes left. And we did cover just like a basic example of an edge computing device, and what kinds of things that we can add onto it, and we tied it back to our wider enterprise discussion design from like episode 1 or 2. What we have planned, we do want to do a demo in the future. I think in a couple episodes from now, we might have a team coming in to show off something really cool, and I'm also playing around with my own device to see what we can do. But we did touch a little bit on AI today. I don't think there's enough time to do a demo or talk about some of the ways that we're making managed services make it easier for people to build with AI. I will give like a sneak preview of what I plan to talk about in those next episodes. So briefly, we talked about all the things that go into interacting with AI. You're pretty much counting on it to do some reasoning and understanding of what tools you're making available to it to do certain things. Would love to show you what that looks like. And then in the context of, say, I'm a platform provider and I'm trying to give useful AI tools to my users, how might I design that so that I can scale to these millions of users that I hope will use my platform and get useful insights out of chatting with this bot? And what are ways that AWS is making it easier for us to build these things? Like I kind of touched upon it when I said you have to understand how you talk to agents or talk to the AI, how you feed it in conversation memory, how you feed it in like more long-term things that it should know about the user every time it's interacting with them, and then being able to like make sure that's secure for different users across different devices and homes. Okay. Where is the buffer? Okay, I'm just reading through the comments again. Victor says hello again. Hello.
Hello, Victor. It's not squared, but it's tripled.
Cubed.
Right after vacation brain. Okay, yes.
Where is the buffer? Not sure. I will never hear the answer. We're trying to answer. Yeah, so did I not put that in?
The data firehouse, right? Yeah, you put it in.
Yeah.
Yeah, the buffer would live inside of the that Kinesis data firehouse layer before going to S3. Yep.
Okay. All right. Anything else you guys want to add?
I think you said you were going to give a sneak peek, right?
Oh, sure. Demo? Should I do the demo real quick?
Why not?
Why not?
Yeah, why not? Do you want to set up what the demo is tackling?
Yes. Or could you set? Oh, okay. I found it. Okay. Let me set up what the demo is tackling. So just, it's in a different context, right? So I don't have a smart home use case for this example, but built this project, which basically is supposed to show off how these concepts work of like talking to an AI agent, what is useful, the entity memory, so long-term memory, the conversation memory. So like as you're talking, like what does it remember about our conversation? And then being able to pull from different data sources and use the idea of tools to either execute actions in different systems or be able to bring in context from different systems into our conversation. So here is an example of an application that represents that. I'm going to hide these tabs. This is a dashboard of just an application that was built. It combines Salesforce data. I don't know if anybody here has worked with Salesforce before, but it's a CRM, which is customer relationship management, which is used to manage customer data. And then the other is Jira, which you're probably people are familiar with that, which is like a project management tool. And what this solution does, it just basically combines data from different places. And then you're able to chat with this bot that is able to bring all that context together. And what is interesting is that we're going to show off a lot of different components of like what you have to think about when you're interacting with the AI and trying to get effective answers. And so one of the things I mentioned was entity memory. Like, what are some long-term data it should know about the user? So like for me, it should know how many devices are active in my house and what they are, and then who I am and like what my preferences are. And every time I'm talking to it, it should be aware of these key information just about me. And then conversation memory is like something you have to manage, right? How big of a window do I want within that conversation while I'm having the conversation? So like, what's my name? Dumb question to ask the AI because I didn't really tell it my name. And then to test the memory, I would say like, what did I just ask you? And the problem with AI normally is that if you're interacting with it just like one-off, it could be stateless. So it wouldn't remember what you just asked it. So like memory is a very important concept. And some of the things that AWS is releasing on Agent Core makes it a lot easier for you to handle memory, not just within the code, but as infrastructure as well, so that you can, as a company building a platform, you're able to scale it out to millions of users effectively. Right, Frank, you're right. AI has no memory, so you have to implement it for them. Yep, exactly. And that was just a sneak peek before we jump into more of the managed services that will help us make building with AI a lot easier. And that is our plan for our next episode.
That's nice.
Unless we have more requests from the audience, like we could cover, Kinesis data firehose in more detail if that's what's needed.
Final question. In the lab, data is going to S3, Kinesis, and EventBridge. If I only want inference metrics, what's the simplest way to filter out raw embeddings at the IoT core level?
Raw embeddings.
Okay, I think raw embeddings is not something that you filter out with IoT Core. If you're referencing like the text embeddings or the image embeddings that Brian was talking about earlier, that's something that you can store in like a vector database, for example, if it's like a text embedding. So I think I might need more information on that question. But if you want inference metrics, depends on what the metrics are, but Amazon QuickSight and Amazon Q could be a good place to start. But that's all I have in like the last 30 seconds before the stream ends. Sorry, Pratik.
Yeah, but want to thank everybody for tuning in. Really happy to answer all your questions as best as we can. And we hope you can join us for the next episode.
Thank you, everyone.
Thank you.